Well, hi and welcome to my shop here. It's January 28th, and today is the day I'm going to play around with this radio. I'm not going to try to improve its operation. I'm going to do a few simple experiments with it. In fact, I made a list of things I'm going to try here with it. I'm going to try to determine what kind of audio distortion is occurring and what levels of signal and settings and things like that. A frequency response, audio frequency response. I'm interested in trying to see that. I don't know how I would do it, but we'll see. I want to look at the noise generated in the radio. Now, the thing about this radio and most HF radios, high frequency radios for under 30 megahertz, is there's a ton of noise on the antenna. So the noise in the receiver really doesn't matter. But I'm still interested in, I have a good opportunity here to do a few experiments here and there and just try to detect where the noise of the receiver itself is coming from. Sensitivity between bands. As I flip between bands, especially on my signal generator back there, the output goes up and down, and so I have to recalibrate it very carefully. I want to do that and take a calibrated measurement of the sensitivity of each band on the radio. And another idea that came to mind is just to stick my antenna here onto my oscilloscope and just see what the heck is on that piece of wire I'm plugging into the antenna terminals on radios. And that's all that's come to mind, but I think as I go along here I'll probably come up with some more ideas. Now I have to let the radio run I'm going to let the radio run for a little while. It's only been on for a couple minutes here, but I'm going to let it run. So I'm going to stop the video shortly and then come back in half an hour or so. And that reminds me, I want to get this going too. Now, most of my equipment is very, very stable, but oddly enough, this guy is fantastically stable. But the newer signal generator, he's crap. This thing takes half an hour to settle down. This guy is very stable. When I leave it tuned to a certain station, when I come back much later, turn the radio back on, it comes right up bang on the same spot. There's no drift in it at all. I know people complain about this radio drifting. I don't know what they're complaining about. So, now, last night I was in here, just a little bit more talk. Last night I was in here a couple times, playing the radio and just seeing, what it can pick up. Maybe yesterday wasn't the best day for shortwave. There wasn't a lot to listen to. But I found a very weak signal on a normal setting, very weak. And so I used the features of the radio to bring out this very weak signal. I basically closed down the bandwidth to cut back the noise. And then I fiddled with the crystal phasing and that. I finally got the voice clear enough I could easily listen to it. It turned out it's just another one of those transmissions from the United States, a religious transmission. Why it was so weak, I don't know, but it was. Because often those things are blasting in here where I live. I listened to this for a while, and I have to tell you, it's the most shocking piece of propaganda, I'm going to use the word propaganda now, that I've ever heard. And I have not heard a lot of shocking propaganda. In fact, I really, Algeria, was it Algeria? It's a small European country that used to, years and years ago, spend half an hour lambasting the United States and their system. And that was the classic kind of propaganda. Never heard anything like that from Russia. The most propagandistic thing I heard, I'm not sure propaganda is the right word for it, before hearing this thing last night, which I'm going to describe in more detail in a minute. I was listening to the American Forces Radio and Television Service. This is years ago again, and this is a service that is provided to the American military while they're away. Maybe they're in foreign lands, and it's something to give them the sensation that they're in the U.S. So it's a very American sort of radio station. It's actually listenable. You can actually sit and listen to it. They play music and general interest things. And just lost the train of my thought here. I just lost the total train of my thought. Why am I talking about Voice of America suddenly? Okay, I don't know. There's just too much stuff in this shop to look at and think about while you're talking. So, let me tell you a little more about the propaganda that I heard. And is this WRMI or something? I don't know. Starts out with a man talking about the American government and talking about white people and saying that clearly the forefathers of the American government were planning a white nation. What else could they be planning? This was the point he was making. Back then, no one ever thought of multiculturalism. There was no multicultural societies on the planet. That's what he said. I'm just repeating what he said. I'm not suggesting this is true or in any way should be followed, or no, absolutely, actually quite the opposite. The reason I'm talking about this is because there's something going on shortwave, which the bulk, of course, of North American people, 99.9%, don't have any clue is happening. But I do, and so I'm sharing it with you, and you watching my videos, you probably listen to shortwave too, and you may have heard this kind of stuff. I hear religious crap all the time coming from the States, but most of it, although it's inflammatory, is, is what it is. But this was not. This was a long sounding like a authority, sounding like a investigator, a researcher, sounding like a factual person, explaining in detail why America is a white nation. I don't know what to tell you. I am telling you. I'm just telling you this is happening on shortwave. Who is listening to this besides me? Who listens to that? What is going on? Again, this is another channel that's open that is conveying crap. Man alive. I got a little tiny tidbit of it on tape too. Just a tidbit. I'm going to check it now and see, because it just as I started recording it, because when I realized what I was hearing, oh my God, I got to get this on record. I tried recording it, but just as I started recording it, faded. So I don't know what I got. I'm going to check and see. So the next thing you hear might just be a little piece of this transmission I heard. A transmission that I think would be illegal in Canada. So I just listened to the recording. It's only 30 seconds long. About the first 15 seconds you can understand, and then after it just gets too weak. That last 15 seconds is out of context for you. I'm going to put it into context. Just before you hear this man speak, what he was talking about was the American forefathers, and just what I was saying before about them expecting the nation to be white and the like. And what he's going to tell you is that if they were alive today, they would be shocked by what has happened to the United States. That's what he's going to say in his own words. And that was part of a long thesis that America was intended to be a white nation, a white European type nation, and not a multicultural nation. Shocking. It's shocking to me. But anyway, so I'll play that now. You can listen to it, and then we'll just carry on with the work here.
And they would be utterly unaccepting of what we have evolved into today. They would consider it a disaster and a travesty beyond comprehension. Many commentators today who are pseudo-conservative,
Okay, let's start with just a little listening here. It's on 6 megahertz. This is not the time to listen to 6 megahertz. What is that? That seems to be everywhere on this. Everywhere I go, I seem to hear that. Okay, so just to hear a station, make a decision of which. Let's try around 11.7. Bingo. Cuba. So by my reckoning, the radio is working really well. Really, really well. But is it working the same on every band? I think that's the first thing I want to do, is check the sensitivity on every band and make it as careful as I can, measurement of it. Again, it may not be so precise, but anything grossly different between them should show up. I should be able to spot something. It might lead me to a problem I haven't yet recognized in the radio. So I'm going to set things up for that. So there's a couple ways I can do this. One is to put in a known signal and then measure somehow how the radio is responding to that. Could use even this meter here if I wanted to. Probably not though. This meter will only activate when you have AVC on. And I discovered last night, and perhaps it's because of the way I've rewired things, that the AVC voltage, the meter which is monitoring the AVC voltage, shows some interesting things when you operate this radio in manual RF control. And to be more specific, you can have a weak signal coming into the radio, and this meter will just sit on 0 here. Once a signal gets strong enough, this will lift off 0 and start going upscale quite a distance, all the way to 50 volts. So I think what we're seeing here is the 27 volt delay. So until the signal gets big enough that it can produce 27 volts at the AVC rectifier, nothing happens. But once it gets above that, we start seeing it. And this is just zooming back and forth like this. If you flip it to AVC, it comes up and it barely moves. That's just exactly what AVC is supposed to do. So what I discovered is in the RF mode, this thing will tell you the signal strength almost directly. I mean, I can't read it off the meter, but I mean you can see what's really happening to the signal. Normally, when you flip a radio like this onto manual control, this meter, which you might rely on, just shows 0. It just doesn't show anything. But with this one, I've managed to show something. This might be a great way to show the response of the radio as I feed in the signal. So maybe I should decide to ask myself this question: what signal has to be on the antenna to make this meter rise to a certain point with this control fixed in some position? Probably maximum would make sense. And then I have to think about this control. As long as I'm not changing it, I guess it's okay, but I could put this wide open. I don't think that will help. I'm going to use a single frequency, so when the radio's tuned to it, it doesn't need much bandwidth. I don't care about the modulation, because the RF part of the signal is what's driving this meter. Okay, I'm going to try it like that. So I have the radio tuned to 40 megahertz right now. I have the signal generator calibrated, and so I know the output of it. Let me just check it. So to calibrate it, we're watching this meter, which is a little far for you to see, and it should be right up at full scale. That's 10 microvolts times 1, 10 microvolts coming out. What frequency? Just under 40. But I have to keep this control here. I can't have this operating and this be in a calibrated mode at the same time. So this is now producing, and I can trust it, I believe, 1 microvolt, 10 microvolts here. What exactly is showing up on the radio antenna, I don't know. We're going to have to assume there's also 10 microvolts here. In any case, this is a comparative study for the most part. There's some information in the manual about what to expect here too, but it's quite complicated, and I'm not sure I even want to look at it. I think I'm going to take this approach. So we need to watch this meter. So I put my headphones on because we need to know when we got the thing tuned in. Let's see. Hello. Hello. Now I need to verify that this is actually the, what we're listening to is actually this guy. I will do that by knocking down the output. Didn't think it's, no, it's not what we're listening to. Okay, maybe it's not coming in. I'm going to raise the signal. It's now 100 times 10, it's 1,000 microvolts. Okay, no doubt that's where it is. 100 microvolts. The meter hasn't moved yet. Well, I got it on AVC. Okay, so we're going to go off AVC. And we're going to go RF right to the top. Okay, that's set full, RF full. Nothing on the meter yet. check the tuning here. Sounds like it's drifting to me. No. I just gotta up the signal level by a factor of 10. Hey, put the meter backwards. It's a negative voltage coming up here. Okay, again, factor of 10. Wow, that's a 50 volt scale. It threw that meter right over. Okay, so a little higher than this is what we want. So this is just to be calibrated. 10. So we can turn this control. We'll turn it to that's 1 microvolt up by 10. Perfect. So I turned it down 10 and then up 10. So it should be pretty much the same. Look, this is slightly off the thing now. Okay, I can manually turn this up. Perfect. And that's me making that meter go up and down. So I'm adjusting. I don't know if you can see this or not. I'm adjusting this. Excellent. So now I can adjust it to a certain number on this meter. 10 sounds like a nice number. 10 would be here. Okay, so that's 10. Now the question would be, how much input have I had to give the radio to get 10 on this meter? And the amount would be, I can read this meter directly. 4 times 100. 400 microvolts. That sounds really poor. .400 microvolts. And the band we're on is the top band. So what would we call that? Call that the 40. Well, I did it at 40 megahertz, so I'll put that right on there. Okay, so I'm going to do the rest of the bands using this procedure. Hopefully, I've done it correctly enough that we're going to find something out here. Okay, good luck to me. Okay, next band measurement. Let's check. So we're calibrated, and right now it's putting out 10 microvolts on the radio. Oh, hello Peanut, we're at 20 megahertz. I don't know why that hum comes in there. It's a little off. Yeah, just give me a minute, Cap. I'll be done this one momentarily. So again, we've got 10 coming in, but not enough to raise the meter, right? We're trying to get this up to 10, so I'm going to do a little thing here, up by 10. Oh, very close. Okay, down on the adjustment, up by 10, down, hit number 10 here. Okay, so we now have a signal going into the radio that generates a 10 on that meter. It's about as safe a statement as I can make. What is the power here? Oh, it's way down there. 1 microvolt times 100. 100 microvolts. 400 on the first band, 100 on the second band. Okay, Peanut, I'm going to come spend some time with you. Yeah, I'm coming. Don't rush me. Okay, the cat's all happy now, so just check to make sure we're tuned dead on. Okay, cut back the signal generator so we're left with 10 on the meter. Okay. That's what it takes to get 10 on the meter on this band. And what does it take? It takes times 10, what's 55? 5.5 times 10. 55. So 10 megahertz. Interesting pattern is showing up here. I'm just going to call it 50 microvolts. 400, 150, that's not a pattern. That was a pattern. Not really a pattern. Okay, next band. I'll get that set up. Okay, so this is at 5 megahertz. I'm just going to make this go exactly to 10. There we are. Okay, on this band, what does it take to make that meter to say 10? It takes times 10, that's roughly 30. I would say 30 microvolts. Okay. On to the next band. Okay, we're set to 2 megahertz. And my meter is pinned over here. Okay, so we're going to reduce the output till we see 10. There we are, 10. What do we got this time? What do we got? Wait a minute, let's just double check the tuning here. The radio. Yeah. Yeah, good. I'll be absolutely sure. 10. We get 10 by feeding in 7 times 10. 70. 2 megahertz, 70 microvolts to achieve the 10. Okay, that was me just wiggling the selectivity control to make sure it's not interfering. It's good. Okay, next band. Last band. Okay, so this is the basically this is the broadcast band, the lower part, the lower 3/4 of the broadcast band. I guess I'm at 1 megahertz. Ooh, look at that meter go. Holy smokes, you see how wide that was? No, you didn't. Wow, okay, so that means I'm putting way too much signal in here. Let's try that. We're down by a factor of 10. Oh, it just about gives us exactly the 10 on the meter. Good. What do we have to stick in the radio to get 10 on the meter on this band? We have to stick 10 times 1 is 10. 10 microvolts. So what we've ended up with here, and maybe this might be reflective of the method I've used to do this. Let me look at it like that. Just as you come down in frequency, you need less and less signal to push that meter up to 10. The meter going up to 10 is indicating the output of the IF. I think it's a pretty valid way of doing this. So what we would see is at 1 megahertz on the lowest band, it's 10 microvolts to get all the way up there, and on the highest it's 400 microvolts. Now there is some information, and it's consistent. 400, 150, 30. Whoops, not quite so consistent. 70, 10. And I wonder what's up on band 2. So band 2 is the upper part of the broadcast band, and then the rest of it is really pretty useless, I think. Oops. Well, yeah, pretty useless. It goes from basically towards the top of the broadcast band up to 3.5 megahertz. Is just nothing there, really there. So I got a little loss of sensitivity here, but what does it really matter? I'm really interested in these bands. These two, mainly. 50 and 100, and I it's the test technique I've used. Let me see if I can now find a proper method that's specified in the manual. I can repeat just one of these, and then I can recalibrate, in a sense, what all these actually mean had I followed the manual exactly. So I'm going to stop and look through the manual to see where it talks about this. So here's a chart, and what this one is saying is what signal strength do you have to inject into what tube pin to get something here, 20 volts, to get 20 volts on the output. That's kind of similar to what I was doing, only I wasn't looking at the output, I was looking at the at a voltage derived in the AVC system. That's about the best thing I can say there. So if I were to try one of these, it's just, so this is a single conversion, this would be double conversion, that's what they're doing here. And they're using the IF frequency. And this is the IF frequency for the double conversion. Approximate input to get that. Well, I might be able to try one of these. I don't want to try them all because I have to switch all these tubes. I don't want to go underneath the set. I'll use the tube extender. I'll pick one of these. Which one should I pick? The one that covers the most of the radio. That'd be the one I would guess would be the one with the smallest input voltage. 70, pin 7 V5. And you flip from this to that on pin 7 V5. You can make these two readings. That sounds interesting to me. Pin 7, and then we can even go, well, that's just V5. V5, 2 tests on V5. That's what we're going to try. Perfect. Pin 7 V5. So in order to do the next test, I have to have a 600 ohm load on the audio output from the radio. So here it is, 600. It's actually 560. And before I hook this up and put 20 volts across it, I thought I bet I should just calculate the power that's going to dissipate from it. And my initial calculation is done with this handy dandy calculator. The amount of wattage that this is going to dissipate, 359,964 watts. I think something went wrong with my calculation here. I better repeat it. Okay, it looks like the correct answer is 0.6 watts. So I mean, this is a, I don't know what this is, 20 watt resistor. This is a whopper, so this may not even feel the warmth. May not even build up any heat in it. So I'm going to put that on the back of the radio, hook it up to the audio output. I checked the input impedance of this meter. It's beyond the range of my meter. So the input impedance is something huge. Maybe there was a capacitor in there or something that was affecting. I just took an ohm meter and just stuck an ohm meter on here. The instructions say it's got to be a 600 ohm resistive load. So I'm making sure that that's the case. I'm going to put this on and we'll attempt to test. Let's push the signal up until this does say what it's supposed to say, 20 volts up to here. And how am I going to do that exactly? Push more signal into it. Do a little more audio. We can put the audio up to, let's say, 40%. And then more RF. Just give it more RF. Okay, down, up, and up. Oh, we're at 20 already. Down. 20. Okay, so there's 20 volts. Now we can say this question. Ask this question. What's wrong with this meter? Come on. I was really hoping this would be up somewhere by now. Then I could relate this reading to everything else. I can't relate to zero. How far off is this from coming up? 30 volts now. So this is RF. I'm going to knock down the modulation here. Bring up the RF. Okay, I've got the meter off the ground. It's a very interesting effect happening here. If you listen carefully to the sound and watch, as soon as that meter starts lifting, coming in there. So that's not going up very high. Let's just put this on 15 volts full scale now. Get it to come up a bit. 2 volts. 2 volts. Turning down the audio now because it's blowing my ears out. 2 2 volts. Where are we at here? So we were trying to drive it up to 10 volts before, so we should drive it up to 10. We should drive it up to 10, and then I'm in a comparative situation. How can I get it up to 10? It was distorting already. What's happening here, man? More RF. More RF. That's way more RF. Okay, set it on 10. Okay, now we have a strong signal being fed into this radio to achieve this. We have 10 though. We have 10, we're at roughly 2 megahertz, so that's going to kind of relate to this number here. So to get 10 on the meter before, we needed 70 on the antenna. To get 10 on the meter now, we need how much on the mixer tube? We need 1,000 times 4. I need 4,000 microvolts. 4 millivolts. So I say 4,000, stick in microvolts. 4,000, is that right? 1,000 times, well, it's almost 5, really. 5,000. 5,000 microvolts. So 5,000 microvolts into the grid, comparably 70 microvolts. That's interesting. 70 microvolts on the antenna. Well, you can't see a thing I'm writing. He says, looking up at the monitor. Okay, so the question would be then, yeah, 70 on the antenna, you know, does it kind of generate 5,000 microvolts at this location where we're doing this test? How can I read this? How can I read this? Just put a meter on it. It's at 500 kilohertz. I'm not sure I can read this. Yeah, I'm not sure I can read. I have a meter that'll read this accurately at that frequency that I can access easily. Anyway, and I do have one. There's one back here. This guy would do it, and this guy might do it. I don't know. Well, I'm going to just accept it as information gathered, and 5,000 microvolts to get 10 sort of, I'm going to call it ABC volts. They're not ABC volts, though. 10 RF, RF volts, RF, I don't know what to call it, 10. 10 volts. Okay, next. Now, what are we going to do now? Must be more fun stuff to do with this radio. Okay, let's do the noise investigation next. So, it's going to be a little bit crude. I'm just going to do some crude stuff here. First, I got to start listening to noise and not this. I should seat this tube right back down the radio for this. So I'm going to take a moment and do that. Okay, ready for some noise experimenting here. The radio's cooled right down, which is good, because I'm going to be pulling tubes out, and once the tubes get hot, it becomes a little bit of more of a challenge. Let me put my headphones on. I don't think I'm going to be doing anything particularly calibrated with this. I'm just going to kind of poke around and try to figure out where's the noise come from. And the thing to keep in mind is the noise generated by this radio is way below the noise that would be on an antenna. So we're going to investigate that kind of thing right away, again, and then we'll carry on from there. So I'm on manual maximum. So there. Okay. And I would like to get this on this meter. I have no antenna. Whoops. sometimes when there isn't enough light, the camera will refocus. Okay, so as I said, we have no antenna hooked up. Conceivably, this is just the noise of the radio. So now, without doing anything, I'm just going to go through the bands and listen to the variation in the noise level. So we're going to start at the lowest band. Interesting, when I'm in between bands, I still hear the noise. So obviously I've disengaged some of the radio, and now I'm going to engage it back. Still receiving. We just changed to double. We changed from single conversion to double conversion. This is single conversion. This is double conversion. That's surprising to me. We've introduced more circuits into the radio, and yet it's gotten quieter. So what this means exactly, I don't know. Just keep going here. A little more noisy. Very, very quiet on the top. Now the top band we discovered is not very sensitive. So that could be why it's so quiet. It's just insensitive. So let's go back to the noisy one here. Double conversion's in place. What happens when I start pulling tubes out? Now, supposedly the noise we're hearing is supposedly coming from the first tube. Doesn't seem very sensitive. I'm doing that with this mixer tube. Seem more sensitive. Okay, so we're going to pull this tube out. It's already way too hot to touch. Too hot to touch. Wow, okay, well that answers that question, doesn't it? That is a major piece of noise dropping off. So, what are we hearing now? Let's take the next RF tube out. I better move this. That's number one, this is number two. No, didn't make any difference. Okay, put number two back in. Yeah, the radio's on, so I don't want to be hoo-ah! A little hotter than I thought. Right in. Let it warm up, see what happens. You can watch the meter here to see the difference. I thought there was a bit of a difference. I guess not. Okay, so if that's not what we're listening to, what are we hearing? What are we hearing? So I'll pull out the mixer tube next. I should put in the first RF tube. It's probably cooled down now. No, don't put that in. Leave it out. Trying to figure out where the noise is coming from. Let's put this back on. Pull this one out. Oops. So, sounds like the noise went down slightly. It's still there though. Happen on another band, so we'll go from this is double conversion, we'll go to single conversion now. Let's see. funny to me that it should be noisier on a single conversion. It just seems to me, you know, there's less stuff. Okay, so leaving that out rather. Just keep progressing up the radio. So the next thing would be the oscillator tube here. Pull this guy out. Can an oscillator tube cause noise? Oscillator circuit? Nothing whatsoever. Okay, put this guy right. He's not very warm at all. Wow. I guess this tube just doesn't get warm. 6C4. In. So probably less about noise and more about keeping the oscillator stable. Having this kind of clamp down right to there. Okay, so where's this noise coming from? So the next place, we're on single conversion now. So a couple of these tubes are not involved. We have the IF string. The IF is going this way, I think. Tube 9, tube 10, tube 11. Where did we pull out tube 11? It's right at the far end. I should keep following along this way. So we have down here we have an oscillator tube, we have a mixer tube, and we have this tube. I think this is the I can't remember the word for it. The tube that operates to bypass the double conversion circuitry. I'll pull that one out. BA6. So we're in single conversion, so this tube should be carrying the signal. I don't know if it does any amplifying or anything. Am I absolutely sure? Yeah, V7. Reach down in there. V7. You know, it's hard to grab these tubes with a towel. Come on. Oh, wow. Oh my gosh, that made a big difference. Okay. And this tube is not very hot either. That just seems kind of strange, doesn't it? That some of these tubes are really hot. Like this is another 6BA6. Same as these two. Which came out quite hot. How do you figure that? Look at this with the thermal viewer. So wow, we just silenced this radio by pulling this tube out. So the noise is either this tube or something ahead of this tube. Wow. I should put another 6BA6 in and see if the noise level is different. This is not a 6BA6. I have one here. This is one of the weaker ones that I took out before. Well, it's just a different tube. Let's try it and see what happens. This is a try it and see deal. Try it and see. Put it in nicely. How come you're making that noise? I didn't even get it in there. Come on. Creeper, creeper. I didn't like that. Okay, got it in. I warm up and hear what kind of noise comes out of this. Okay, so on the noise meter, we've got, this sounds a little quieter, doesn't it? This could be a weaker tube. The whole radio could be quieter, when the whole thing could be weaker now. Yeah, I did mix the tubes up. So I stuck a 6BE6 in to that V7 spot for a 6BA6, and no wonder the radio was quiet. I'm lucky, you know, that something terrible didn't happen when I did that. So, but the consequences of all this is I've mixed up the three 6BA6s. I used to have the strongest one in tube 1 position. I want to do that again. I gotta find it. I gotta find which one of these is the strong one. So we're way up here at 27 on this guy. 27. Waiting for a big snowfall today, coming this evening. Look at that. That's our number 1 guy there. So I'm going to pull him out and I'm going to stick it right into V1 position here. Well, I won't stick it in just yet. We're going to listen to it while I stick it in. And then this one. I'm assuming the strongest tube should be in the first tube position. We put a weak tube there and expect the radio to work better and be more quiet. There's another one that's right up there. So this one's going to go into position 2. There's already a tube in position 2. How does this work? I've got 3 tubes out of the radio and only 2 empty sockets. Wait a minute. No, I've got 2 tubes. Okay, so this guy's going to go in. I was wrong. I was right. I was wrong. You know what? I do have 1 more tube and I have empty sockets. What have I done? Okay, so we're going to put in the first tube here. Lost complete control of my experiment. And we don't have the, I gotta put the one in down there too. Put a good one in, I gotta test one more. Guess I had a spare one on my bench that I've grabbed. Right over, super good. That one's going in. Good. Okay. Still don't hear anything coming out of the radio yet, but I'm going to put this one in, then we're going to hear things properly. Okay, going in the socket. Oh, instantly. I can hear something. So the tube before tube 7 I think would be tube 5 in fact. That's my telephone doing that. Yeah. I keep it in my breast pocket, you know, so I can microwave my heart periodically during the day. Cover. Cover. Now, so we've been listening to this noise, but the radio's been wide open the whole time to hear this. So what we're going to compare now to the level of noise that's on the antenna, on A antenna. V antenna. A antenna. This is the antenna connection. I think I have the antenna switched on down here. Doesn't really matter. We're not trying to pick up a station. We just want to introduce the normal antenna generated noise here. I'm going to turn the radio way down so we can just hear a little bit, because I'm anticipating a big jump up. So what that shows you is the noise level of the receiver is so far down. Why would I even care? And now we have an interesting display on the scope there, and I'm not even sure what it is. What we got? We got... This is an unbalanced thing here. If this is the audio signal in the back of the radio, it should be up and down. It shouldn't just be down. What am I looking at? I can't remember. Looking at... Ooh. What's all that? What's it doing? Maybe I have this thing up so loud it's ridiculous. Wait a minute. It's still recording. We're looking at the signal earlier in the radio. In fact, the volume does nothing. And the RF gain, yeah. So I'm going to switch to AVC. Same thing. This may mean nothing at all. But I would normally think a signal would be up and down, not just down. Could we hear something like that? If that's what we're listening to, would we recognize it? Probably not. Probably not, without some kind of comparison. So what have I got going here that would do that? So the scope, what is the scope? The scope, I think the scope is looking at the IF output. I can't get back there. I gotta get you out of the way here so I can get right back there. See, what have I actually got the scope hooked up to? Diode output. I believe we're looking at the diode output. Well, maybe that's just fine then. Okay, we're on every darn time. Just don't know what that little tone is that you can hear. It could be some kind of interference here in my shop, or even an artifact of the audio system. I do have my soldering iron on. Jeez. Soldering iron causes that interference. It's a bad actor. My radio's decided my camera won't focus. Oh. Focus. Let's see what we can pick up on the radio. Really on the wrong band. Go up. Quieter on the double conversion for reasons I haven't got a clue. And we'll go up to 11.7 in this area here.
Christmas meals family will love. Go to preparewithbethann.com to get your food kits today. The future is so uncertain. I urge you to go to preparewithbethann.com and get ready now. That's preparewithbethann.com.
What are we preparing
Hi,
for,
this is
Beth Ann?
Beth Ann. The inventor and CEO of MyPillow is always looking for ways to solve everyday problems. Have you ever picked up a towel set because it felt so soft in the store, but then when you got it home and tried to use it, it wasn't absorbent at all? That's why MyPillow has developed the MyPillow towels. Towels that work, I know, it's mind-blowing. Towels that actually will dry you. They're debuting the MyPillow.
Oh, he's becoming the My Towel guy.
Set that includes 2 bath towels, 2 hand towels, and 2 washcloths. They come in a variety of colors, and right now you can buy one and get one free with the
on
promo
shortwave
code
radio.
BethAnn. Go to
It's a commercial
mypillow.com now
shortwave
and click on the
radio
radio
station.
listener special.
Coming out of the States
MyPillow
for sure.
products come with a 10-year warranty with their 60-day money-back
Rock solid
guarantee.
signal.
To get your buy one get one
And it
free
fades out as I say
MyPillow
that.
towel set, go to mypillow.com, click on the radio listener special, and enter promo code BethAnn, or call
Well, listen to this on
1-800-978-6. Promo code is BethAnn.
There's nothing wrong with global communication.
So,
After all, high
just getting up a little bit on here.
seems smaller.
Cut off the
Now we
signal.
hear terms such as global governance. Henry
Now
Lamb's
watch the
book,
scope.
A
Now
Short
the scope's
Course in
become
Global
interesting
Governance,
now.
is a clear education indeed regarding
Up
the
and down on
importance
the
of
RF
knowing and
gain
understanding global governance. Do you believe the UN should have power over the United States, any other nation, With global governance, there is no sovereign United States of America. Read firsthand and learn the true agenda of global governance. America says private property shall not be taken for public use without just compensation. However, global governance says private ownership of land contributes to social injustice. Public control of land use is indispensable. Learn more now. A short course in global governance is only $7.50. Visit our online store at csctalkradio.com.
I don't know, you call that kind of stuff propaganda? Is that what that is? Or is that educational material? Well, what is that?
A short course in global governance.
Global governance. Nice sound.
Radio. This is Beth Ann. Well, I said I was going to share the devotional.
I talked over when she said
this morning. I thought it was very
Bye, Beth
appropriate
Ann.
for.
Now, I'm not on ABC, so if you notice, I've left the signal and the radio is very, very quiet. We're listening to the antenna, and if you had the ABC on, the radio would jack up its strength a lot. And you get that. It gives you a false impression that there's piles of noise, but there really isn't between signals. It's much better to cruise along in the RF control, and then you turn up high enough so you can hear a little bit of what's coming in on the antenna, so you know you got it up high enough, and you just go on from there. If you turn this down just a little further, these signals will come right out of silence. Almost silence. That's Cuba in two places. Beautiful. The radio's working really nice.
Está cerrado el acuerdo con el gobierno uruguayo y que no está definido el número de vacunas.
Havana, Cuba. Lots of shortwave from Cuba, and I can receive it. That's why I hear a lot of Cuban shortwave. We're almost noon here, so let's take a shot at 15 megahertz, 19 meter band. Now I know you can't see the frequencies on. That's just below 20 megahertz, whatever that is. We're around 17 megahertz now. That I keep coming across, I believe, is some kind of interference coming on the antenna. It's coming up on 16, the noise level's going up.
Gentlemen, we were sitting on a bench start exposed to an oncoming hurricane. The good police officer said that she would stay for a hotel room for them if they have nowhere else to go. The good Samaritan replied, I don't even know your name. They can help you. Then the officer took them in the hotel for tonight.
So this could be coming from anywhere.
Later leave. Fortune from her police department. Bless you, Corporal R.A. Selassie and the Good Samaritan. Your Lord in action exemplifies a warm-hearted community.
I'm going to guess it's a broadcast where the material we're listening to is coming from a smaller country, and they bought time on a larger transmitter. I'm guessing. That happens quite a bit. So a small country can get its voice out. In other cases, there are countries using shortwave as a regular broadcast for their country still. Yeah, like North America, we're not invested in shortwave. Parts of the world are heavily invested in shortwave. So hoping they'll identify themselves here. Sounds like they're just going to play this song. But we're going to move on. Moving on. Just can't quite get it clear enough to understand. You take out too much trouble, there isn't enough there for you to sort out what you're hearing. It just becomes a bunch of mumbling. It sounded like an African voice to me. Not much. So now you're hearing WWV and you're hearing some heterodyne with it. So there's a chance, I just can't get that to come into the camera. There's a chance, it's right on 15 though. The heterodyne is coming from WWVH in Hawaii. There are times, if you do radio listening, I'm sure this has happened for you too, there are times where you can hear WWVH at the same time you can hear WWV. It's a woman's voice that comes on ahead before the male voice on the Boulder, Colorado signal. Just faded right out. Yeah, that tone means it's lunchtime. So radio appears to be working really well. That's just the impression I get from doing these things. Great, lunchtime. So thanks a lot for watching this so far. I don't know if I'm going to do more or what I'm going to do. I don't know what I'm going to do. I just like listening to this radio a lot. So see ya.